Hello, my dear cooks and scientists. Welcome. I'm Aida. Today we will see how to obtain smooth and creamy kidney beans while saving energy and increasing the nutritional value. In the experiment, we will see the difference between not soaking the beans and soaking them in different solutions. First of all, let's see how we are going to develop these experiments. We will handle 5 samples: beans without soaking, beans soaked in water, in brine, in water with baking soda, and beans soaked in a solution that simulates hard water, for which we will use a calcium chloride. In all the samples, we will use the integrate quick soaked method. In the experiment, we'll use kidney beans, which are large red beans, known as kidney beans because of their shape. These beans are some of the most difficult to cook. We are going to weigh 200 grams for each test. To have reasonable control of the experiments, we'll use purified water. With this, we ensure that the water has few dissolved minerals and that there is no other interference in the experiments. We poured 480 milliliters of water into previously labeled jars to later prepare the solutions. We're going to prepare the brine soaking solution using regular sea salt. Many other chefs and cooks propose using 15 grams of salt for every liter of water. Since we are using 480 milliliters of water, we'll use 7.5 grams of salt, equivalent to a half of a spoon. This 7.5 grams of salt contains around 3 grams of sodium. We'll use 10.8 grams of baking soda, about 3/4 of a tablespoon for the following solution. In this 10.8 grams of baking soda, we also find 3 grams of sodium. We do this to be able to compare 2 different solutions with the same amount of sodium. Hard water is water that contains a high concentration of dissolved minerals, usually calcium and magnesium, in the form of carbonates, chlorides, and sulfates. We'll use 440 milligrams of calcium chloride, which contains 160 milligrams of calcium. With this, we are going to simulate very hard water. We are going to measure the pH of the solutions. Purified water has an almost neutral pH between 6 and 7, it is 6.5. The pH of the brine solution remains unchanged at 6.5. The water with baking soda presents a pH change around 9.5. The addition of the calcium chloride to the water does not modify the pH. It's kept around 6.5. We add the solutions to the beans and heat them to a boil. Once it reaches the boil, keep it for 2 to 5 minutes and remove it from the heat. We keep them covered and let them rest for 30 minutes. While I'm sampling these beans and these solutions, let me tell you the following. Legumes are one of the essential components of a balanced, healthy diet. They are rich and well-known source of nutrients, including proteins, carbohydrates, minerals, vitamins, polyunsaturated fatty acid, and biologically active phytochemicals that benefit human health. But they also contain compounds that interfere with the absorption of nutrients and can be considered toxic, like the protein called phytohemagglutinin, which is a lectin. Its concentration is measured in hemagglutinated units. Raw beans contain about 70,000 HAU, while cooked beans contain between 200 and 400 HAU. The consumption of 5 raw beans could cause nausea, vomiting, abdominal pain, diarrhea, and even take us to the hospital in less than 3 hours. Soaking the beans and especially boiling them for 30 minutes reduces their toxicity to edible levels. That is why we must take sure to keep the boil during the process of cooking the beans. Using a slow cooker to cook this type of beans is not recommended. In fact, it would be preferable to use a pressure cooker in which the cooking temperature is increased. In addition to this lectin, beans contain carbohydrates and fiber that humans cannot fully digest. This fiber passes from the stomach to the intestine, where the bacteria in the intestine ferment it, generating gases, among other substances. No soaking or cooking method completely removes these toxic or anti-nutrient substances. Studies have shown that these anti-nutrients are beneficial to human health in specific amounts. A bit contradictory, right? So it is advisable to moderate the consumption of legumes. The Diet Guide for Americans recommends consuming 1.5 cups of legumes or beans per week, while in the health system of the government of Mexico, the consumption of half of a cup of beans or legumes per day is recommended. We discard the soaking water of all the samples, and now we'll cooking the beans with 2 cups of water. We use only purified water so as not to have any other interference in the experiment. We put all the samples to cook over medium heat. Once they start to boil, lower the temperature slightly, making sure to keep the boil. As you can see, I took on the task of measuring 10 beans for each sample. But let's go straight to the results. In all samples, we use the integrate quick soak method, varying only the type of soaking solution. And sometimes we had to add more water during the cooking due to its evaporation. None of the solutions changed their pH. They all remained between 6.5 and present brown tones. With an exception for the solution of sample number 4, beans soaked in baking soda solution, with a pH between 9 and 10. The soaking solution has an intense red color, while the solution after the cooking has a light reddish color. Let's observe and taste the already cooked samples. Unsoaked and water-soaked beans have no flavor and feel watery and soggy. This is also reflected in its weight. We see that these 2 samples are the ones that absorb the most water. The beans of sample number 3 have a more pleasant flavor and consistency than those without soaking and soaking in water. The beans of sample number 4, beans soaked in water with baking soda, have a smooth creamy texture and slightly salty flavor, but are different from the sample number 3, beans soaked in brine. Beans soaked in calcium chloride solution taste slightly salty, but less so than those in sodium chloride. They have a firm texture, and the sample that did the shorter cooking time. The winning sample is sample number 4. Beans soaked in water with baking soda. Second place, sample number 3. The beans soaked in brine for 1 hour and 50 minutes cooking time. Thirdly, we have the beans soaked in water with a cooking time of 2 hours. The beans that came last are the beans that are soaked in calcium chloride solution with 3 hours and 20 minutes of cooking. We can see significant differences in cooking times with different soaking solutions, right? The weight of the beans increased between 152% and 210% of the original weight. The beans' volumes or size also increase. The graph is represented to scale, and the dotted line represents the original size of the beans. To calculate the energy used, it was considered that each stove burner consumed 1500 watts per hour and is multiplied by the cooking time. In a simplified way, we can say that there is lower energy under the same conditions in a shorter time. We will analyze the results in parts. We will first see these 3 samples: beans without soaking, beans soaked in water, and beans soaked in brine. All samples took around 10 minutes to reach boiling, plus 2 minutes to keep for a total of 12 minutes of energy consumption. We need to add 30 more minutes at rest in a matter of time. Do we spend less time on brine beans? Do we use less energy? The difference is minimal. In this sense, we do not observe a difference between not soaking the beans, soaking them in water, or soaking them in brine. However, brine-soaked beans have better flavor and texture.
Why did the beans soaked in water increase more its mass than the beans that were soaked in brine?
It is a good question. To answer this, we need to explain the following. Pectin is a substance that, together with the fiber and other plant carbohydrates, is responsible for the rigidity of the plant, in this case, the stiffness of the beans. Let us imagine that these spheres represent this structure. The structure of pectin helps hold water inside plant cells. Therefore, pectin is insoluble in water, but with the application of heat, the pectin becomes soluble, which allows the flow of liquids between the plant cells and the solution of the medium, causing the loss of the rigidity of the bean. In the integrated quick soaked method, the applied temperature will partially destroy the pectin. allowing the bean to rehydrate more quickly. When the beans are not soaked, as in the sample number 1, the rehydration and the cooking process occur practically simultaneously. But when we cook the previously rehydrated beans, the cooking is carried out more homogeneously. When we soak the beans in a solution that contains sodium, either because of the salt or the baking soda, the sodium takes the place of magnesium and calcium, destabilizing the rigid structure. This allows or facilitates the flow of the liquids from the solution into the bean, but also from the bean into the solution. This is why beans soaked in a sodium-containing solution are smaller in size than beans soaked in water alone, where the flow of water between the solution and the bean is less dynamic. When only water is used in the soaking process, the bean continuously absorbs water. The inside of the bean hydrates much faster than the skin, which causes the bean's skin to break. I must clarify that beans with broken skin were observed in all the samples. But this phenomenon is observed more in sample number 2, which is the beans soaked in water. Now let's look at the results of samples 3 and 4.
Why sample 4 takes less time to cook the beans if we use 2 solutions with the same amount of sodium?
Good question, Arthur. Well, another important factor comes into play here, which is the pH. The baking soda reacts with the water. One of the reaction products is sodium hydroxide, which is a base, providing hydroxyl ions to the solution. These hydroxyl ions facilitate the dissolution of the hemicellulose in the cell wall. In other words, it also helps to soften the rigid structure of the bean and speed up the rehydratation and cooking process. Studies on different kinds of beans have shown that soaking them in baking soda solution increases their nutritional value by increasing protein digestibility and antioxidant capacity. And on the other hand, it helps reduce anti-nutrients such as hemagglutinin activity, phytic acid, and tannic acid, among others.
Why did sample 5 take so much longer to cook?
Hey Arthur, you notice it. You don't miss a question, do you? Let's see why it takes longer. Remember that calcium and magnesium are like the glue that holds together the blocks that form the bean's rigid structure. So, if we soak the beans in a solution containing excess of calcium or magnesium, their structure will not be affected. That is why calcium chloride is used as a ferment agent to keep the structure of some fruits and vegetables firm and crisp in pickles and canned food. In fact, calcium chloride is used in making canned whole beans. In this experiment, we use an excess of calcium to simulate a very hard water.
Okay, a lot of exciting information, but how is the recipe? Or are we keeping it a secret?
No, Arthur, we want that everyone to have access to a recipe where, in addition to obtain delicious and nutritious beans, they can save time and energy. So our recipe is as follows. We kept constant the amount of beans, which was 200 grams. We also kept the volume of the soaking solution constant using 2 cups of purified water. But we reduced the amount of baking soda by using only 5 grams, which is equivalent to 1 teaspoon. The pH of this solution is between 9 and 10. We kept the process constant, that is, we boiled the beans to boil with the soaking solution, kept boiling for 2 to 5 minutes, and let them rest for 30 minutes. We also discard the soaking water. This time we will modify the cooking process using 3 cups of water. In this step, we are also going to season the beans. I like them to be a bit spicy, so I am adding a chile de árbol. This is complete to your liking. In Mexico, it is usual to use epazote to cook the beans because it helps to the digestion of the beans, reducing the production of flatulence. I like beans seasoned with oregano or thyme, and a bay leaf also gives a great taste. This time, I'm going to choose thyme. I'm adding 1/4 teaspoon of dry thyme.
You should use epazote. I don't want to be here when you eat those beans.
We also add 6 grams of salt, equivalent to a teaspoon. We add some garlic, and I like to peel the garlic and chop it slightly, because in this way the garlic dissolves in the bean broth. We could also add some onion. We tasted the beans, and after about 50 minutes, they seemed to be done. In short, our final recipe could look like this. We are proposing the amount of baking soda and the salt in the range where you can adjust it to your diet if it's low in sodium or to your taste.
Is there nature to cook any kind of beans or legumes?
No, but we will explain that in another video. Thank you for watching us, for sharing your experiments, your results, your questions, and for subscribing.